Homework out, books open to page 198. Homework out, books open to page 198. You had just 6 problems for homework. Number 1, number 2, and numbers 5 through 8.
Oh, 5 through 8?
Oh, Lana.
Oh.
Did you do 5, 8?
Well, we will call on Lana to do 6 and 7, and she will make it up that way.
I thought you
'Cause
said
I have
1, 2, 5,
1,
and 8.
2, 5 through 8. 5 through 8.
What does through and sound like? How does that sound like the same thing?
I mean, it can't be a...
Number 1. What do we need to do to solve this equation, Lana?
distribute.
To get?
5x positive 15, negative 7x equals negative 5.
Then what do we need to do, Adam? Just look at the chalkboard, Adam. What do we need to do next?
Solve the problem.
Yeah, by doing what, Adam?
Adding the positive 15 to negative 7?
No, Adam. This isn't a negative 7.
Subtracting the negative 15, positive 15 with the negative 15?
There's a negative 15?
Right. No.
We have an exam coming up soon.
Yeah.
I foresee weeping, wailing, and gnashing of teeth.
I can't find the problem.
You don't need to find the problem. You just need to know what to do in this one that's already on the board.
Negative, put a negative 15 on both.
Why would you do that, Adam?
There's a positive.
So we just get rid of everything? Should we put a negative 5x and a positive 7x also? Just get rid of everything?
I was just trying to solve for x.
Which x, Adam?
The little, like x. I don't.
That's kind of hard to solve for x when there's 2 of them, right?
Well, you put the negative 7 and the 5x and you get negative 2x.
Oh, combine terms to get negative 2x. Very good. That's what we should do next. There we go. And we get the positive 15 all equal to negative 5. Good. So we get rid of parentheses. We combine like terms so that we don't have lots of different x's rolling around in the problem. Now what will we do, Adam?
Put a negative 15 on both sides.
Now let's put the negative 15 on both sides to get
negative 2x equals negative 20.
There we go. And then Dylan.
Divide away the negative 2.
There we go. And of course, negatives cancel, 2's cancel. I'm just left with x. Over here, class. Positive 10. Those negatives cancel. And when I divide, I get 10. Or you say negative divided by negative gives you positive. How many have 10 for number 1? Questions on number 1. Number 2, what do we need to do here, Joshua?
Like, distribute.
To get?
3x positive 3 plus 2x negative 2 equals 16.
There we go. Then what do we need to do, Lana?
5, you combine the x's to get 5x. And then positive 3 equals 16. I mean, no,
Combine the x's to get 5x.
equals 16.
Good. Combine the nothings to get positive 1 as well. Alright. Then what do we need to do, Dylan?
Subtract 1 on both sides.
To get?
5x equals 15.
And then what do we need to do, Adam?
Divide, you get positive 3.
Divide the 5 away to get x equals 3. How many had 3 for number 2? Good. Number 5. It says to add or subtract as indicated. Of course, on number 5, we're just adding. So we just combine the like terms together. So we've got a 3x squared y in the first polynomial. What is like to that, Dylan? What?
Negative x squared y.
The negative x squared y. So if we have a 3x squared y and a negative x squared y, we get?
2x squared y.
And then we see a 2xy. What's like to the 2xy, Adam? We're on number 5 in your book. Number 5 in your book. In the review section. There's a 2xy. What is like to the 2xy in the second polynomial?
In the review section?
Yes, the review section, where the homework was. Page 198, Adam. Where you are. Look at number 5. Look at the
number
problem.
five.
There are two
Five.
polynomials we are adding. In the first polynomial, we see a 2xy. I'm looking for a like term in the second polynomial.
X, wait, 5xy?
The 5xy. And when we combine the 2xy and the 5xy, we get
7xy?
7xy.
How do we-
I'm going to get so many dislikes on this video. I have a positive xy squared. What is like to the positive xy squared, Joshua?
The positive 2xy squared.
And when we combine them, we get
3xy squared.
very good. Now, if I were doing descending order of x, this could work. If I were doing descending order in general, this is third degree, second degree, third degree. Maybe we flip-flop them. It's really hard to do a true descending order anyway, so maybe we just leave it like this. How many got that answer on number 5? And number 6, Lana didn't get an answer yet.
Oh.
But Lana's going to get an answer right now and atone for her wickedness. Lana, I see a 5xy in the first polynomial. In the second polynomial, what's like to it?
Negative 6xy.
Let's combine those to get.
Negative 1xy.
Lana, I see a negative x squared y. What's like to that?
Nothing.
Nothing. It has no friends. So what do I do?
And just leave it.
Negative x squared y. And then I see a positive 2x. What's like to that?
Positive 3x.
To get.
Positive 5x.
Then we look at the second polynomial. Is there anything without a friend?
4xy squared.
Yes. And we don't want to just get rid of it just because it doesn't have a friend. So we keep the 4xy squared. How many had this answer on number 6? Lana has it now.
I'd flip the last two.
Right, and again,
Yeah.
these terms can be in any order because addition's commutative as long as you have these 4 terms in your answer.
I forgot the xy squared. The 4xy.
Yep, careful.
Yeah.
All right, numero 70. Lana, it says to subtract, but we know we don't subtract. What do?
Add the inverse.
So first things first, there in your book, go ahead and make sure you've added the inverse on all of those. That way we can do what we were just doing, because what we were just doing was easy. Right, Adam?
Mm-hmm.
Yes, sir. So number 7, Lana, we have a 5x squared. Like to that is a?
Negative 8x squared.
To get?
Negative 3x squared.
Then I have a negative 7x. Like to that is a?
Negative 6.
Negative 6x to get?
Negative 13x.
Negative 13x. And then I have a negative 9. Like to that is a?
Negative 5.
To get?
Negative 14.
And we get a very negative answer. How many have this answer just chock full of negativity? Good. I feel a kindred spirit here. All right, number 8. Lana did do this one. We have another subtraction problem. Again, we need to add the inverse. What do we get for our answer here, Dylan?
6x squared, negative 12x, negative 19.
6x squared, negative 12x, negative 19. It's moments like these that you wish you could be at like Scott at home, hitting the forward arrow, skipping 5-second chunks to get from one answer to the next. Well, you can.
You can skip on YouTube.
Yeah, like on YouTube, you know, if you hit the, like you have the little forward and back arrows, you go forward 5 seconds, backward 5 seconds. Like if you're like, wait, I just missed what? Like if I'm watching highlights of a game or something, like, you know, I'm not really paying attention like I should because I'm distracted by small chair. I'm like, hey, it's out of there. Whoa, what?
Are
Back
you
arrow.
recording live form, or is he gonna watch it like
No,
this?
he watches these later. No, I record and then upload later on in the day because he's sleeping right now anyway. So
He's actually like 12
Yep,
hours.
hi.
he better be sleeping right. Well, no, he might not be in bed yet. It's like 9:24 their time at night. So he might not be in bed yet.
That's what they're like 12 hours.
But by the time I upload, he'll be in bed. So you can watch it when he gets up in the morning. First thing in the morning, it's like, oh, I'm tired, but math class, and I'm energized and ready for the day. Right, Scott?
No.
Right.
Joshua doesn't
Scott?
feel that way. All right. Anyway, questions on the homework.
Is that a stroke?
Okay.
Anyway. All right, turn it over, look across the page. Page 199. Page 199. I'm going to really test your brain power here. I want you to do page 199, numbers 3 through 19, every other odd.
Every
Every other odd. Okay, y'all got this? So We do 3, and then what's the next one you'll do?
7.
7, good Adam. And then after that you'll do
11.
11,
Oh, yeah.
right? And then after that,
15.
15, and then
19.
right in 3 through 19, every other odd. All right, go.
Kind of weird.
I wouldn't want you to get bored, Lana.
Bring back.
Exam coming up, not in the next lesson, but in the one following. For you guys, that'll be Monday. Scott, it'll be lesson 43. So a good review of some of the more recent material we've talked about, some of the untested material, or as yet untested.
How you do it?
I'll go back and look it up in your notes then, or look it up in the book. All right, let's take a look at these together. Number 3, what is that thing? Degree and classification based on number of terms. Joshua?
7th degree mononomial.
It is a 7th degree monomial. Remember, for each term, you're going to look for the sum of all the powers. And so it is a monomial to the 7th degree. Number 7, what do you get when you subtract those polynomials, Adam?
3x squared negative xy positive 1. Like,
Oh, Adam.
the wrong problem.
No, you did the right problem, but we did it wrong. When we subtract, we need to do what?
It would wouldn't it be positive 5xy?
It'd be a positive 5xy, and
Positive 13.
make sure when we add the inverse, we change all the signs, right? So we end up with a 3x squared, positive 5xy, positive 13. Let's see, number 11, when we multiply those monomials together, sign, number, letter, what do we get, Dylan?
Negative 8x to the 4th y to the 6th.
Negative 8x to the 4th, y to the 6th. Number 15, when we raise to the power, well, what do we get, Lana?
4x to the 6th.
4x to the 6th. And number 19, when we multiply that monomial by the polynomial, we're going to have to distribute to get what? Back to Joshua.
12x to the 4th negative 6x cubed positive 12x.
12x to the 4th negative 6x cubed positive 12x is correct. Anyone go 5 for 5? Got them all. Okay, Dylan, good. All
I
right.
missed just number
4
3.
for 5, just because I added
Number 2.
I just
Alright.
missed the degree one.
All right, questions on that? All right, go back and do the every other odd, 1 through 21. Go back and do 1 through 21, every other odd. So all the odds we just skipped over.
You could have just said 1 through 19.
No, because I wanted you to do them in 2 rounds. So for instance, on the degree thing, if you forgot how that worked, you could have a quick review before you did another problem. You see how that works? Is the mastermind, the master teacher, shining forth, burning education into your soul, coming this October. I'm trying to think of a cool name for the movie, and I didn't. Sound like a movie preview though. I couldn't think of a cool name for the movie, so there goes that. The return of the math class. Viewer discretion advised. I always advise discretion. The phantom mathness. Revenge of the math teacher. Return of the exam.
Or you could just say
Math teacher strikes back. Or the whole movie series.
It's like a new Goosebumps series.
No, new Star Wars. Give us
Obi-Wan Nadesky. Princess Lana.
what?
Han Joshua.
What's
He said
Dylan and
Princess
Adam then?
Leia. Well, maybe Chewie.
Alright.
No, I think Adam's more.
Lana.
Joshua from John's.
What happened to this class?
Wait, can Scott still
He can still hear us, yes. Fighting against the evil Darth McDonald.
You say Darth McDonald.
Potential.
Oh.
This is.
I saw that.
C3 Krasinski.
What is it?
C3 instead of C3PO. R2 Dylan.
What is it?
R2 Dylan.
That doesn't even sound.
No, that once we got past Princess Lana, nothing really had the right feel. Like the syllables and the vowel sounds, nothing really fit well. I did a grocery store wars spoof years ago when I said Darth Tater, Princess Lettuce,
Princess
Obi-Wan Cannoli, Chew Broccoli. Look it up on YouTube sometime. All right, that's trying to drive people to other channels. or trying to get Scott to get distracted and start watching other videos while he's supposed to be watching my math class. Let's go ahead. Let's take a look at these. Number 1, there's a lot of different terms in the polynomial. Remember, within an individual term, you add up the exponents. But for the polynomial as a whole, you just find whichever term has the highest degree. So, what is that thing in number 1, Adam?
The fourth, fourth degree trinomial? No. What is polynomial?
It's just a 4th degree polynomial. There we go. We don't have a special name for it because, once you get past 3 terms, there's not cool names for stuff. But it's a 4th degree polynomial. Number 5, what do you get when you add those together, Joshua?
2x negative 10.
2x negative 10. Number 9, when you multiply those together, what do you get, Dylan?
12x to the 5th.
12x to the 5th. Number 13, when we raise to the power, Adam?
X to the 12th.
X to the 12th. Number 17, here we had to raise to a power, then multiply together. What was your final answer, Princess Lana?
108x to the 8th, y to the 17th.
Your Highness did well. 108, 8x to the 8th, y to the 17th. How many also got that answer?
Multiply those?
Well, because they're up against each other. So we're going to raise to powers first, right? Order of operations, exponents before multiplication. So raise to powers, then we're going to multiply. So when we raise to the power, of course, we're going to get a 27x to the 6th, y to the 9th. We're going to multiply that by a 16x squared, y to the 8th. And a 4. See, that's a 2. That's a square. It's not a 4th power. Anyway, 4x squared, y to the 8th. There we go. And then we multiply. That's where we get the 108x to the 8th, y to the 17th. Because we raise power to a power, multiply the exponents. Multiply like basis, add the exponents.
That's a weird problem.
Yeah, that's a great problem. Great problem. Then number 21. Back to Joshua. When you distribute, you got
Negative 2x to the 6th. Negative 2x to the 4th, positive 8x cubed.
close. Remember, when you multiply like bases, you add the exponents on that first term. You're multiplying sign is negative, number is 2, but x should be to the 5th power. Negative 2x to the 5th, negative 2x to the 4th, positive 8x cubed. Anyone go 6 for 6? How about 5 for 6? 4 for 6? 3 for 6? 2 for 6? Just kidding. Other questions?
1 out of 6.
Any of them? Questions on any of these? Questions on any of these?
No.
I'll have to edit that out. Questions on any of these? All right. Turn back to page 105 as we continue reviewing for your exam. Page 105 in your textbooks. And we see a variety of equations there on the review section. I want you to do the numbers 1 through 6 on the review. Page 105. Review 1 through 6. Got a couple absolute value equations in there. Got some other miscellaneous equations as well. That's one of the chapters that we talked about. So there will be a number of those. Not as many as the last test, because the last test was all equations. But it will be a significant portion of the exam coming up in lesson 43 on Monday. Yes, sir.
Why Monday? That's after the weekend and everyone's brains are dead.
Yes, it's unfortunate.
That's the first class too,
Why
so we
do
don't
you
get
even-
warmed up.
They should make a law, no exams on Mondays.
Well, see, we were supposed to take exams Tuesday through Friday. And then everything got pushed back 2 days. So now we're taking exams Thursday through Tuesday. Because remember, you got the first 2 days of school off?
Don't blame everything on that.
No, that's the thing we blame on it. Yeah, just shift everything back.
Is there anything else that they cut out because of that?
Well, for instance, tomorrow was supposed to be a half day. Now it's not a half day.
It was supposed to be a...
Well, because it was going to be the end of the quarter. The quarter was going to be done. You're finished with your exams. We're not done with the quarter. We're not done with exams, so we couldn't do it.
Wait, so are we gonna have a half day?
No.
Not till Christmas.
So sad.
No breaks until Christmas?
Well, no, you get breaks. You get Veterans
Oh,
Day
yeah.
off and
All right.
Thanksgiving break off, but we don't have any half days until Christmas.
Oh.
The last day of the semester will be a half day.
Oh.
And Scott's back there laughing, saying, ha ha ha, every day for me is a half day. Quiet, Scott.
Yeah, be quiet, Scott. We're not in
You
our
fast
lives.
forward through YouTube videos for sure.
You know he's your uncle. He has authority over you.
He doesn't...
He's only a half uncle. He only has half authority.
He doesn't have a real school life.
We love you, Scott.
Do we?
Do we really?
I don't even know.
I think people who watch the video the next year be like, who's Scott?
I don't even know.
Dylan doesn't know Scott anyway, he just likes picking on him. It's okay.
I'm replacing you, Scott.
No,
Oh, no.
no, you're not.
Oh no.
No one can replace him.
Scott, you live in-
So, Joshua and Lana, several students are watching the videos we recorded last year in 8th grade. And even though they don't get addressed by name,
Oh, I know. So.
Yeah, right. And so Jaden, for instance, was telling me she laughs when I pick on Scott.
Isn't
She did.
isn't Kyla too?
Kyla as well. So I guess the Scott jokes can still be funny for other people too, just not as personal, except for Scott. Because that's the upside of being the first guy to have to watch him. After that, nobody really gets talked to.
What's the 8th grade video?
Well, he's not watching 8th grade videos. So we have some 8th graders watching 8th grade videos.
I probably sounded kind of weird back then. Still kind of sound.
Only when you talk about
I mean, it is kind of true.
Remember, for an absolute value equation, the key is to get the absolute value by itself. Isolate it. Don't distribute. Isolate. And then once it's by itself, we make how many equations? 2 equations. So we should have how many answers? 2 answers.
Okay. Oh, okay.
Yes, sir.
I think some wacky answers in number 3 and 4.
That's possible.
I'm gonna whack answer on number 6.
Yes, sir.
Can you distribute in number 5 with the absolute values of 2?
What did we just say, class? And what did I emphasize before the last test when I taught absolute value?
Isolate.
Isolate. Don't distribute into it. Isolate.
How do you do?
Well, if there's something in front of it, you wanted to multiply it, right? Divide it away.
Don't you get rid of the thing that's after it or something?
Yes, yes. Because it's less attached. It's like the stacking donut rings. The thing that's up against the absolute value is like baby blanket. We get rid of that last, but we do get rid of it. So the absolute value can stand on its own feet and say, I am a man. Well, anyway.
I still have my baby blanket though.
Well, you're not a man, so it's okay.
Oh,
But I
Now,
don't.
Joshua still had his baby blanket.
He does.
And Scott slowly tucks the baby blanket behind his back.
It's not like they carry it. It's not like I carry it.
Yeah,
I don't
around.
own it anymore.
I don't even.
All right, let's take a look at these together. Number 1, no parentheses, right? No combining we can do, but we do need to get rid of the little x, which is which one, class?
The 2, right?
The negative 2x.
Negative.
By putting a positive 2x on both sides. That's going to be a 6x, and the 2x is going to cancel. Positive 5, all equal to 17. Of course, at the same time, we could say, well, since I have the x's over here, I know that 5 is going to need to go anyway, so let's put a
-5.
-5 on both sides to get 6x equals
12.
And so we get x equals 2 for our answer. How many had 2 for number 1? Number 2, once again, get rid of the little x, which is the 2x by putting a negative 2x on both sides. That just gives me a plain old x, right? Because 3x negative 2x is x. At the same time, let's get rid of the 5 by putting a -5 on both sides. But that's putting a -5 with a -6 to get
-11.
And there's our answer. X equals -11. How many had -11 for number 2? Oh, questions on number 2?
I think I accidentally added the x's on the end instead of subtracting.
Oh, be careful. Number 3, we got to distribute first to get what, Adam?
I don't think I got this one right.
Number 3, Adam, what do we get when we distribute?
Plus 7x plus positive 18.
How about 4x plus 12
Whoa.
plus 6 negative 3x equals 10. Does that sound good? When we distribute the 4 and the 3?
Yes, sir.
And all right, now let's combine like terms, Adam.
I got 7.
Well, let's try combining a 4x with a negative 3x to
I
get.
didn't do that right.
Yeah.
1x.
X. And of course, you're right about this 12 and 6 giving you an
18.
18 is equal to 10. And then what do we need to do,
Oh,
Adam?
that is right there. Well, you subtract the 18 with the negative 18 on both sides, and you get the negative 8.
There we go. How many x equals -8 for number 3? Careful when you're combining like terms. Number 4. What's the little x, class? 4x. By the way, notice here, I don't get rid of the little x. Why not?
Because
it's already
They're on the same side. Right? You just combine them. If you can combine them, you combine them. But on number 4, they're on separate sides, so you can't combine them. You have to get rid of one. We're getting rid of the 4x by putting a negative 4x on both sides to get 2x plus 4 equals -8. But I want to get rid of the plus 4.
-4.
-4, that cancels it away. I put the -4 with the -8 and I get.
-12.
So what do I get for my answer on number 4? -6, our answer. Number 5, I've got a 2 times the absolute value of 4x -8 minus 3 all equal to 5. And the first thing we got to do is isolate the absolute value. 2 numbers that are with the absolute value. What are they, class?
-3 and 2.
The 2 and the -3, but the least attached is the
Negative.
So let's get rid of that first.
Positive.
Positive 3 on both sides to get 2 times the absolute value of 4x minus 8 is equal to
4. No, 8.
8. Now we're going to get rid of the 2. Not distribute the 2, get rid of the 2. It's being multiplied, so how do I get rid of it, class? Divide it away from both sides. That knocks the 2 out. Now the absolute value of 4x -8 is isolated and equal to
8 or 4.
4. So now I make 2 equations. My first equation is going to take whatever's inside the absolute value and say, well, that right there could be
4x.
4, or that right there could be
Negative.
-4, right? Because the absolute value of 4 is 4, and the absolute value of -4 is 4. So the 4x -8 is either equal to 4, or the 4x -8 is equal to -4, or both, right? And so now in both cases, we're going to want to get rid of this -8 so we can get the x's by themselves. How do I get rid of the -8? Positive 8. I'm going to, by the way, be a little too lazy to write it on both sides. I'm just going to put the positive, because I already know it's going to cancel here, right? It's almost as if, listen, the -8 moves over and becomes a positive 8. You could think of it that way. You could think of when it changes sides of the equal sign, it changes signs. Or you could be putting a positive 8 on both sides. Either way works. So then with the 4x here is equal to 12. But here, a 4x is equal to 4. And then we divide by 4 and we end up with 2 answers. First x equals 3, and then second x equals 1. And so 2 possible answers for x. And we got 3 and 1 for number 5. Questions on number 5? Number 6, I've got a 7 times the absolute value of 5x plus 6 plus 8 equals 22. What do we need to do first here, Joshua?
-8 on both sides.
To get
7 times the quantity.
times the absolute value.
That's what 5x positive 6 equals 14.
There we go. Or you could say you move it over as a -8 and you get 14. Either way you think of it, you're getting a -8 over there. Then what do I need to do, Adam?
Divide 7 and 14 and
On both sides, right? Divide the 7 on both sides. You get the absolute value at 5x plus 6 equals
2.
2. Then what do we need to do here, Dylan?
Make two equations.
What are they?
5x plus 6 equals 2. 5x plus 6 equals negative 2.
And in both cases, to solve for the x's, I'm going to have to first, Lana,
negative 6 to both sides.
good. We'll move over as a negative 6, either way you want to think of it, to get 5x equals
Negative 4.
and 5x equals,
Negative 8.
negative 8. And when we divide by 5, we get a couple weird looking answers, class. X could equal,
Negative
4
4
fifths.
or x could equal.
Negative 8 fifths.
They're both just a little weird. Now there's one little glitch. Suppose this had been not a 22, but just a 2. When I move the 8 over as a negative 8, class, or subtract 8 from both sides, I end up with
Negative 6.
negative 6. And I divide by 7, I get negative 6 sevenths. The fraction isn't the problem, but the fact that I would have an absolute value equal to a negative means I would have
No solution.
no solution. Questions on that?
No.
Read word problem number 7 for us, if you would, please, Joshua.
Wait, so is it? No,
Negative 8 fifths and negative 4 fifths are our answers.
Oh.
We were done with the problem. I was just showing if, because I wanted to review, if absolute value is equal to a negative, it's no solution. All right, number 7, Joshua, read that for us.
After playing 25 basketball games, Hickory Hollow Christian High won 4 times as many games as they lost. How many games did they win?
All right, how many unknowns do we have here, class?
2.
They are.
Wins and losses.
Which one gets to be X?
Lost.
All right, at your seats. Represent the unknowns, set up your equation, solve. Oh, got it. All right, did we represent wins as 4x, class?
Yes.
And then so wins and losses together, or 4x plus x, or better yet, 5x, equals the 25 games played. You don't have ties in basketball, so x must be 5, but that was the losses. It asked for the wins. So 20, our answer. How many had 20? How many forgotten left to answer is 5. That would be a sad season. Well, I guess for us it wouldn't. Anyway, number 8. Go ahead and read that one for us if you would, Lana.
Number 8.
Yes.
Our class made Jeff, Chad, and Lane ate a total of 254 marshmallows in the marshmallow eating contest. Jeff won by eating 7 more marshmallows than Chad, who ate 5 more than Lane. How many did Jeff eat?
All right, how many unknowns, class?
3.
Jeff,
3. What are they?
Jeff, Chad, and Lane.
Jeff, Chad, and Lane. Sounds like they had a lot of important things to take care of in that class meeting. And who gets to be X?
Lane. No.
Why?
Because it's the one
Came
it goes
back
back
to
to.
Right, Jeff ate so many more than Chad, ate so many more than Lane. It ends up coming back to Lane. Okay? Who is defined in terms of Lane?
Chad.
Chad. How do I represent Chad?
X plus 5.
X plus 5.
X plus 5. Okay? Jeff, though, is not defined in terms of Lane. Jeff is defined in terms of Chad. So if Chad is X plus 5, and Jeff had 7 more marshmallows, then Jeff would have had
X
X
plus
plus
X.
12.
X plus 12. You could say X plus 5 plus 7, but that's going to end up becoming X plus 12 anyway.
Can you put X plus 7?
X plus 7, huh?
Oh.
Okay, Jeff Lana had 7 more than Chad. Chad is X plus 5. So Jeff had 7 more than Chad, which is where we get the X plus 12. Does that make sense? All right, as you see, it set up the equation and solve. Considering they had a total of 254 marshmallows consumed during the contest. That's a lot of marshmallows.
Were they tiny ones?
Probably the little ones, yeah.
I hope not the big ones.
That would be...
They'd probably get sick.
They would.
I don't know if I've ever... A marshmallow eating contest. Like, usually it's like, how many marshmallows can you stick in your mouth and still say Chubby Bunny? But, and you're like
That's
drooling
not
out
very
your mouth and
gentle
like...
because
marshmallow
What if
fluff
you
is like
choked?
oozing out.
I mean, what if you choke?
I don't know. I've also done like you toss the marshmallow and try to catch it in your mouth. I've seen that before.
This goes back to this time. We were playing marshmallow dodgeball. You have cups stacked on one side. You have to try to like knock the
It
cups
was
down,
weird.
but if you get hit by one, you're out. It was insane. Like
There was
someone
one.
threw
But
it.
anyway, work on the problem. This isn't helping you with your exam.
It's easier.
I know, that's what I got.
It's 79.
Huh?
Because
it is.
3.
Oh, that does come out evenly. Okay.
What?
It does.
I got 2x plus 70.
Oh, there's 3 people. X plus 12, X plus 5, and X. So that's 1, 2, 3 X's. That's why. Alright, check your work. Should have been X plus 12 plus X plus 5 plus X equals to 254. Or you could combine from here and say 3X plus 17. They're already in nice neat columns anyway, equals 54. Move the 17 over as a negative, or subtract 17 from both sides. Get 237 divided by 3, get 79. That's Lane, that's X. 5 more than that is Chad. 7 more than that is 91. Or you could say 12 more than Lane is 91. The only answer they were interested in, though, was how many did the winner eat? How many did Jeff eat? And 91 marshmallows is our answer. That's a lot of marshmallows. Questions?
91?
Well, because X is 79, right? You got X equals 79? Okay. And Jeff is X plus 12. So if you add 12 to 79, you get 91. Or you could go progressively and say Chad ate 5 more,
Oh, okay.
and then progressively Jeff ate 7 more than Chad, which would give you
Yeah.
91. All right, number 9. Read that for us if you would, Adam.
The senior class of Oakdale Christian School traveled 630 miles in one day on their trip to the Grand Canyon. After lunch, they traveled twice as far as they did before lunch. How many miles did they travel after lunch?
How many unknowns do we have, class?
2.
2. What are they?
Lunch.
Lunch.
This is traveled lunch.
Before lunch.
Before lunch and
After
after lunch. Right, there we go. So it's like, we define history as BC and AD. Well, we can define the day as AL and BL, right? Before lunch and after lunch. So before lunch, after lunch. Before lunch, everyone's upset and grumpy, and after lunch, everyone's sleepy. All right, so, all right, so which one gets to be X? Before lunch or after lunch?
After lunch.
Before lunch. It says after lunch they travel twice as they did before lunch. It comes back to before lunch. Before lunch is X. How would it represent after lunch?
2x.
2X. They travel twice as far. HC set up the equation, solve.
It seems like they always travel more after lunch on everything.
Got it.
Me too.
And they want to know how many miles after lunch. Since it said, by the way, how many miles, it asked that you use the unit in the question. We don't have to write the unit. If it said how far did they travel, we would say 420 miles. Okay, but it didn't say how far. It said how many miles. Well, it's this many miles, right? The miles was already included. Nothing would be wrong to include the unit just as a precaution. Questions on number 9? All right, your homework for this evening is to do page 199. Page 199. Numbers 2 through 22 to even. Page 199. Numbers 2 through 22 the even. And on page 105, do word problem 10. On page 105, do word problem 10. One more time, page 199, 2 to 22, the even. And page 105, word problem 10. In our next lesson, we'll be doing our last review before the exam, and of course Monday will be the exam. Have a wonderful rest of your day. And when the bell rings, you'll be
Bye,
dismissed.
Scott.